Before start this video, please subscribe my channel and click on bell icon. Thanks.
Based on our simulations, we think that the overall concentrations of these reactive species in the lungs are large anyway, and not directly dependent on levels of air pollution, says Dr. Thomas Berkemeier, head of the Chemical Kinetics Reaction Mechanisms group at the MPIC. They use a computer model to understand the relevant physical, chemical, and biological processes, and quantify the health effects of different types of air pollutants. Our new model simulates the chemical reactions that happen in the respiratory tract. For the first time, we included production, diffusion, and removal of hydrogen peroxide from cells in the bloodstream into our computer model. This was quite challenging, because it is not so easy to put these processes in biological tissues into equations, explains Thomas Berkemeier. New research directions. The findings of this study suggest that the current paradigms for assessing the differential toxicity of individual PM2.5 components need to be critically reassessed, says Professor Dr. Ulrich Possel, head of the multiphase chemistry department at the MPIC. The study proposes that the chemical production of superoxide and H2O2 in a cell-free assay may not be a suitable metric for assessing the differential toxicity of individual PM2.5 components, and some acellular oxidative potential assays may not capture the actual deleterious effects of PM2.5. Fine particulates might act through Fenton chemistry. However, the production of hydroxyl radicals, OH, was strongly correlated with Fenton chemistry of PM2.5 in the model calculations. The model simulations suggest that PM2.5 mostly acts by conversion of peroxides into highly reactive OH radicals. Thus, PM2.5 is not so much the fuel, but rather the catalyst of the chemical reactions that cause damage to cells and tissues, says Berkemeier, explaining the role of inhaled particles in the model. Additionally, PM2.5 stimulate the production of superoxide from endogenous sources, which further contributes to the adverse health effects of air pollution. The study underscores the importance of continued research to better understand the chemical mechanisms underlying the health effects of air pollution and to develop effective strategies to mitigate these effects. The authors believe that this study will contribute significantly to this important research effort. Their findings are published in the scientific journal, Environmental Science, Atmospheres. Background information: air pollution is a major health risk that affects millions of people worldwide, but the underlying chemical mechanisms are not yet fully understood. Fine particulate matter, PM2.5, typically contains chemical components that can trigger oxidation reactions. When inhaled and deposited in the human respiratory tract, they can induce and sustain radical reaction cycles that produce reactive oxygen species, ROS, in the epithelial lining fluid, ELF, that covers the airways and alveoli in human lungs. Numerous studies have shown that excess concentrations of ROS, like hydrogen peroxide, H2O2, and hydroxyl radicals, OH, can cause oxidative stress, injuring cells and tissues in the respiratory tract. Thanks for watching. Please subscribe my channel for more videos.